So we are given a right circular cone in which there is a tiny opening here at the bottom, and the radius is 4 inches. And there is a fluid filled into this tank, and because of this opening, so the fluid is leaking from this opening. And what we are going to do is this, that we are going to assume that the rate of change of volume is an empirical constant, and I think this constant should be between 0 and 1, and the area of the opening times the square root of 2gh, where h is the height of the cone, or height of the fluid in the cone. I think it'll be better if we just put a negative sign here, because I did say that this is between 0 and 0.1, right? Okay, so A0 we can easily calculate. And before I go ahead, what your problem asks you to do is, it asks you to find an equation in dH over dt. So we have to set up a differential equation in dH dt. All right, so first let's settle this value, A0, or area of the opening. That will be how much? That will be pi. So pi times 4 over 12, I changed inches to feet, square feet. And this quantity C is given to be 0.6 in your problem, right? Okay, so that is 0.6, and this is pi over 9 if we simplify. So what we can do is note that 0.6 is how much? That is 3 over 5, right? So 0.6 is 3 over 5. So we can simplify this whole portion as pi. This would be 1 over 9. Okay. And C is 3 over 5. Okay. And so that will simplify to how much? Pi over 15. So we can rewrite this equation in a shorter form. So that is replace this CA0 with how much? Pi over 15. So, and keep this in mind that h is the height of the fluid, okay, like remaining fluid that has already drained at the instant t. So let me revise the picture, okay. So say the fluid has drained down to this level, okay. And so what happens when that is, I apologize, just a second. So just trying to show it dynamically. I don't know whether it's worth it or not, but you will see. Okay, so all this fluid is gone, okay. And then what we have is that we have the height of this portion at time t as h, right? Now you can simply use trigonometry and see that the radius at this time will be what? H times, how much would that be? Tangent of 30 degrees, right? Okay. So as I just told you, that this is what, let me increase the thickness here. This radius is h times tangent of 30 degrees. Sorry about my pen. I'm using different computer right now. So this is h times tangent 30 degrees. Okay. So now we know that g is 32 feet per second square, and 32 times 2 is 64, whose square root is 8. So what this entire equation will change to is that we just have what for this? So here we will have 8 pi over 15, right? And then we will have a square root of who? Simply, let me just write h in handwriting, square root of h. Now let's go towards dh dt, because we have to find an equation in dh dt. So now first let me go ahead and erase this area so that we can write over here. Okay, so I'll get rid of it. And then we know dv dt, and we have to find an equation in dh dt. So notice this here, that v is how much? 1/3 pi times radius, which is h tangent 30 degrees square, times h, pi 1/3 pi r square h. And we know that tangent of 30 degrees is how much? 1 over square root of 3. So square root of 3 would be a 3. So what this quantity will become then? This quantity is going to become 1 over 9. 3 comes here, joining this 3 makes a 9. And then this will be h square multiplied with this h. It will be h cubed. So our v simply becomes how much? Our v becomes 1 over 9 pi h cube. Now we can differentiate both the sides by or with respect to. So when we do that, what will we get is simply dv dt would be h cube when it's differentiated with respect to t. By chain rule, we will get 3h squared dh dt, and that 3 will reduce this 9 to a 3. Now we know that our dv dt is how much? Our dv dt is this quantity that we just did. All right, let me bring it up here. So what will happen then? This quantity becomes equal to, let me erase this now. Okay, so these two are the same, and now all that we have to do is solve for dh dt. Okay, so I'll just let you solve it at your own time, and you can see that this equation will reduce for you to is this equation, giving you a differential equation in dh dt. All right.